Using similar figures. Now, figures are similar when two figures have the same shape but not the same size. If they were the same size and the same shape, then they'd be actually what is called congruent. But we haven't gotten there yet, so we will. But if you look here, you've been working with similar figures your entire life as a kid. Every square is similar to every other square. Every circle is similar to every other circle. But most polygons, which are just many-sided figures, do not have to be similar. So that's why we specify when we're working with similar figures. A lot of that has to do with because it's working with ratios and rates to compare the two. So if you look here, they have the same angles and sides that each match up to form the same proportions. So if you look here, we got here polygon A, B, C, D, E, F, and polygon G, H, I, J, K, L. Now what shape are those? Wait for it. They are hexagons because they are six-sided figures. And what we need to do is to show that they're actually similar figures. What we do is we just go ahead and we refer to them in the correct way with what matches up with what. In this case here, just about everything matches up except for the angles. If you look closely, the angles are a little bit different. So I do have to be specific on those. And the way you indicate an angle is by doing this. So angle A is similar, that's what that means, to angle G. And angle B is similar to angle H. And let's see here. And so then we just keep on going around. Angle I, and we can start from the other side too, is similar to angle C. And you get the idea. I'm not going to go all the way around there just because I'll run out of space, but just they have to match up. And for each of these things, you have to show that it's the case. Well, actually, I am, because it's just good practice, I guess, to go ahead and, well, let's see. So angle F. And you have to make sure that they all match up right. So angle F is similar to what angle? Well, look over there. It's angle L. And angle E is similar to angle K. And the last two, they're going to be similar. So we've got 6, so it's going to be angle D is similar to angle J. Okay, so pretty simple on the angle front. And most of the times if the angles are all the same, then actually we'll have similar figures, it seems. But just to make sure, we have to go ahead and compare the sides as well. In this case here, well, hey, check it out. All of them, AB, AB, BC, CD, DE, EF, all of them are equal to 5. So I'm just going to write down sides equal to 5. And over here, the sides are going to be equal to 7, each of them, right? Sides, I guess if we look closely there, we see, hey, all of them are 7. Now, so these two are similar figures. And if I wanted to do it the real way that you're supposed to do it, what I would say is I would, to indicate this, and I'll show you that in the next problem, I would go ahead and say, well, A, B is equal to 5. That's how I indicate A, the value of AB is equal to 5. And the angle and the value of GH is equal to 7. And this may seem a little bit odd, but so anything here that's a 7 is going to correspond to something over here that's a 5. So we can actually form a ratio between the two polygons, which is a 5 to 7 ratio. So if I were to change this and make it double this size, double the size of this smaller one, then everything wouldn't go to 7, everything would go to 10, and all these numbers, there's 7 over here, would be 10s, because I would have doubled the size of every single part of the polygon. So that's the beginning understanding. I know sometimes that's a little bit hard to understand, so that's why I wanted to spend a little bit of time going on this. So now we're going to move on to the more relevant in terms of the actual examples. And what I do here is, these would be two triangles, and they're triangle ABC, and triangle DEF. And the first thing I always do when I look at these sort of things is I see, well, hey, do all the angles match up? And in this case here, hey, check out 30, 30, 75, 75, 75, 75. So I know for sure that the angles match up, because if the angles don't match up, then it's not going to work. And sometimes the triangles can be placed in a different way. Like if I were to rotate this a little bit so that the D was down here, it would look a little bit different, but I could still tell that there's a 75-degree angle here, a 75-degree angle there, and then be a 75-degree angle up here, because it would rotate, the F would rotate up to there, and then the D would still correspond, be similar to the A up here. It would just be, sometimes they trick you up and sometimes they'd flip it all the way over, and so just be careful on that. And so what I have to do to make sure that these are similar, that's the first thing, the angles. And now I go ahead and I look at the sides, and here, well, I got 8s over here, and then I look at what the corresponding side is, and then that's going to be a 10. And now I look over here, see, well, I got an 8 over here, and a 10 again. And all these form ratios, though these two ratios are equal, so now I have to see if this ratio is equal. Well, I got a 4 over here and a 5 here. So 4 and 5. And if you were to multiply both these top and bottom by 2, you'd end up with 8 over 10. So we have similar figures, because they're all, the ratio of the different sides are the same, and it's equal to 4/5, and then the angles are all the same, so we have proven that they are similar figures.